Doing 1.4 notes number 2, so day 2 of notes. And our goal today is to solve and graph compound inequalities. Solve and graph compound inequalities. So what does this word then, compound inequalities, mean? Okay, compound are like putting two things together. Have you heard of compound words? Okay, so that's like the same idea. So you're going to put two inequalities together. So this contains at least two inequalities that are separated by either the word and or the word or. So then we have the idea of using one of those two words. And the idea of this intersection is if we use the word and versus the union will be if we use or. So I'm going to take you through a little scenario, okay? And so it's not math related, it's about your cats and dogs at home. I want you to raise your hand if you have a cat at home. Okay, raise them high so we can see who you are. If you have a cat at home, raise your hand. Okay, raise your hand if you have a dog at home. Cool. So raise your hand if you have a dog or cat. If you have a dog or cat, put your hand up. Okay, so there are a couple different options of what your house could look like if we say who has a dog or a cat. Okay? Here, I'll do it on the scrap paper. If we said or, there are three different options of what could be inside your house. What's one of those options? A cat. So you could have just a cat. What's another option? A dog. What's the other option? Yeah, you could have both at home. Maybe you even have multiples at home. So there's lots of options about what this could look like. Okay? Now I want you to raise your hand if you have a dog and a cat at home. Who has a dog and cat? Okay, do you see the difference? Because if I'm asking who has a dog and a cat, it only looks like one thing. There's only one way this house can look, and what is it? A dog and a cat. Okay? It cannot just have one or the other. So what's going to happen is we have to graph the two inequalities. And then what I like to do is I like to use colors. So if you have colored pencils or highlighters, that might be a good idea to help you see. And when it's an or, you could say, let's say the colors were blue and green. You could say it could be blue, it could be green, it could be blue or green, and that's my solution. Okay, and then we can use that to draw our final graph. Here, you're looking for where is it blue and green. So where on the graph is it both blue and green, and that's going to be your solution. So we kind of have to do a sloppy copy, and then think back to this of what our options can look like, and then do our final graph from there. Does that make sense? Does this make sense with the dogs and cats? Okay, so then hopefully we can change it to colors once we get there. Okay, so the and is, it's called the intersection of two sets is going to be A and B. So there's that and word. And the union, this is going to be this set made by combining the two. And if you want to write in there to like help you remember the who has dog and cat versus who has a dog or a cat, and you could even draw in the pictures of the houses like we did, but maybe that will just kind of help trigger what we talked about with the dogs and cats. Okay. Steps for solving and graphing compound inequalities. The first thing that you're going to do is you're going to separate the inequalities into two inequalities. So you're going to think about them as two separate problems. And then what you'll do is you'll solve both of those. And that's where you're going to do a rough draft of your graph. Okay. When we're determining the solution, the and has to be the overlap of the two colors. Because it has to be where the blue and the green is at. Okay? If it's the or, it's going to be that anything that's on that graph. So we have some examples here. You have an inequality, and you have another inequality. Now, we don't know how to graph this right now because right now it's not solved. So we are going to have to get x alone. Okay? So to get x alone, we're going to ignore everything over here. We're going to look at just that inequality that's there on the left. And we have 3x minus 1. So the first thing that you're going to do is add 1 to both sides. (3x) is greater than negative 27, so you're going to have to divide both sides by 3. I'm not going to flip the sign because I divided by a positive 3. X is greater than negative 9 is what I have so far. Okay. All right, we got to do the other one now. Subtract 7 on both sides. So it's almost like you have two problems here, but you're just doing them back to back. And then they're going to only have one graph in the end. 2x is less than 12. Divide both sides by 2. X is less than 6. Now, if I just have this as my final answer, that's not going to be right because I need, this is a compound inequality. There's two of them, but I have to join it with a word. So what was the original word? Was and, so I have to make sure that I write and in between those two words. Otherwise, it's not your solution. Okay? You're not specifying what your solution is. That and or is the most important part about that compound inequality. Okay, so that means what I'm going to do is I'm going to color code these. And I'm going to make a rough draft before I put it on my final draft here. So when I make my rough draft, I know I'm going to have something at -9 and something at 6. So I'm just making a rough draft. Okay? And since it's an and, I'm going to be looking where it's both colors. Okay? So maybe I'll do this one in pink. So I have an open circle at -9 and it's going to the right. Okay. Maybe I'll do this part of it in green. That's an open circle at 6, shaded to the left. And since it's an and, where is the graph pink and green? Yeah, between those open circles, right? So I have to make sure that my final draft, all I'm going to do, I use my rough draft graph to say, okay, where is it green and pink? It's in between -9 and 6. So I need to come up with, maybe I'll go up by 3s on my scale. Okay, so I have an open circle at -9, an open circle at 6, and it's just shaded between the two because that's my final solution. Do you see that? So here it was green and pink just between that -9 and 6. So when I drew my final copy of my graph, my final solution, I needed -9 on there and 6 on there. So I made sure to come up with a good scale where I get both of those numbers. And then the only place I shade, the only place that it was green and pink was in between those two numbers, so I made sure to shade in between those two numbers. All right, so the next one is an or, and that one can look a little bit different, okay? Because if I asked you on this rough draft, where is the graph either just green, just pink, or green and pink, what part of the graph would we have to color in? Where else? Why can't you do the middle? That's where the cat and the dog lives. Yeah, but it says or. Remember, they could have a cat, they could have a dog, or they could have both. So here you could have green, you could have pink, or you could have both. So what part of the graph would we have shaded in this case, if this was an or? How about the whole thing? Right? The whole thing has color. Here's just green, here's just pink, here's where they both are, so I would shade the whole thing on my final graph. If we have a graph that the whole thing is shaded, do we remember what that solution is? Not no. All real numbers. Everything works. The no solution is when you shade nothing. Okay? Which sometimes you'll have that in this case too. You just have to look at your rough draft and say, where is it, pink or green, on the whole thing? Maybe it's on none of it. Okay? All right, so let's try this one. This is an or one, so we're going to solve each one separately. So add 2 to both sides on that left one. Start by adding 4 to both sides. Divide both sides by 3. All right, so I'm going to have to do my rough draft over here. Don't forget that we're going to have to put that or word in between the two. I'm going to need a -3 on my rough draft, and I'm going to need a 4 on my rough draft. So on this one here, I'm going to use a closed circle on 4. Let me label this one the pink one. I need a closed circle on 4, and I shade to the right. Remember, don't forget, you always want your variables on the left because then that shows you which way to shade your arrow. Okay, so that's that one. Go for the other one. This one's going to have a closed circle on -3. And it's less than, so we shade this direction. So where is it, green or pink? It's only on the sides this time, okay? So on our final draft, here's 0, 1, 2, 3, 4, 5. We get 1, -2, -3, -4, -5. I'm going to do my closed circle at -3, shaded this way, a closed circle at 4, shaded this direction. Okay. Do you see how you can use that rough draft though? You always want to have that rough draft. I do have colored pencils I can probably get out if you would like colors. But if you have two, I mean, even if you have a pen and a pencil, those are two different colors that you can separate. Okay. All right, let's go ahead and flip this over. And there are 4 practice problems, so I'm going to give you some time to go ahead and work on these 4 problems. Okay. This one, let me just give you a hint. You can write this as 2 separate inequalities. This is actually an and inequality. Okay, so if you look at this, here's one of them. -8 is less than 2x plus 9. That's one of them. The other one is 2x plus 9 is less than or equal to 11. That's your other inequality. So you have 2 inequalities there with an and between them. So you can choose to solve it like that. Or when you're solving this one, you just solve it by, if you wanted to get x alone, which x should be in the middle when it's alone in this, you would just subtract 9 from all 3 parts. So it's like an equation that has 3 parts to it. Okay? It doesn't necessarily have 3 sides, but 3 parts. So that's what it is so far. So you can choose to leave it all together, or you can break it up into those 2. Or you can do that at the end. So once you divide by 2 on all 3 parts. Now you could write it, this one, that inequality right there, I would write it x is greater than -17/2. Remember, if you want to flip it, you have to rotate the whole thing. So this would be x is greater than -17/2. And the other phrase is x is less than or equal to 1. So now we can write it as a compound inequality. These two mean the exact same thing. Okay. And see if you can graph that. So I'm going to pause it there. And you guys can solve A, B, C, and finish graphing D. Okay, so let me unfreeze my screen. There we go. I went through and I got all the way to the part where I did my rough draft graph, and now I wanted to at least discuss that stuff with you. So on this first one, it's an and statement. How did we do on getting x is less than 6 and x is less than 9? Raise your hand if you got that part. If you got this part for the solution. Okay, good. All right, so then I did my rough draft and I said, okay, if it's less than 6, I have an open circle at 6 shaded to the left. If it's less than 9, I have an open circle at 9 shaded to the left. Where on this graph is this graph pink and green?
On the left side.
on the left side right here. So that means my final copy of my graph, what I'm going to do is I'm going to have to put an open circle at 6, and it's shaded to the left. That's what's going to have to be on my final copy. Does that make sense? Because that's where on my graph there was the pink and the green was up to 6. And then 6 was an open circle. This is just green, so I don't get to shade that on my final copy. Is that an okay idea? Okay. Now, if I were to just graph this, what would I tell you that that solution is? Because you can describe that with just one inequality instead of writing both of those. How would you describe this this solution, this graph? X is what? It's a less than because it's pointed in this direction. Remember when you're reading this, you read it from left to right. So the left side is the smaller side, so it's less than. Not or equal to, because we have an open circle. And what number is it less than? 6. So that means I actually could describe this by just saying x is less than 6. I don't even need a compound inequality to describe that solution. Is that okay? All right, let's look at B. So x is less than 4 or x is greater than 5. Raise your hand if you got that far. Okay, good. Good. I graphed this one in pink. I graphed this one in green. And this is an or statement. So remember, this is where your house could have a cat, your house could have a dog, your house could have a dog and a cat. Okay, so that means my graph could be pink, my graph could be green, or my graph can be pink and green. So what parts am I going to have to graph on here? I think my final draft should look just like my rough draft, right? Just one color, I don't need two anymore. So I can even go up by half so that they're a little bit further apart. Open circle at 4, shaded this way. Open circle at 5, shaded this way. Okay, part C. X is less than or equal to -3, or x is less than 4. How many of you got that far? Got to this point? Good. All right. So I did this one in pink. So a closed circle at -3, shaded to the left. An open circle at 4, shaded to the left. Okay, it's an or, so your answer could be pink, your answer could be green, your answer could be pink and green. So what part is going to be my final answer here? How am I actually going to graph my final solution here? What is it? That would be if it's an and, but that means it would just be here if it had to be pink and green. That is part of the solution, but you're allowed to have just pink and you're allowed to have just green. So that means this is going to be part of your solution also because it's an or statement. Okay? So where should my circle be on this graph? Where should I have a dot on this graph? At 4. I don't even need a dot at -3 because I only need that open circle at 4. And it will be shaded to the left of that. Okay, well this is actually just a single inequality also. I don't need a compound inequality to represent this graph. So how would I represent this graph? How would I describe this? X is less than 4. So this is just a simpler way of writing that solution. because I don't need that long, lengthy solution for that one. All right, on this one, it does not matter which way you write the solution. I typically leave it like this. I like to write it like that, or you can write it like this. If you're leaving it like this, okay, you're thinking about as x has to be bigger than this number, and x is smaller than that number. This number is your smallest, this number is your biggest. It goes in order. Your signs always have to be going in the same direction, because if you were ignoring this x here in the middle, this number is smaller than or smaller than 1. These signs have to be the exact same because this number can only be smaller or bigger than this other number. It can't be both, and those signs have to represent both of those statements. Does that make sense? So you have to be able to say negative 17 halves is less than 1, or I could say negative 17 halves is less than or equal to 1. Okay, and it fits both of those. So my signs have to go the same direction because a number is not going to be smaller and bigger than another number. Okay. So my signs are going the same way. If they are, what I know is x is between this number and this number. If you write it out like this and you graph it, you can see that our overlap, because this is an and, is in between those two numbers. But I always think that x is literally written in between these two numbers, and a lot of times when I see this, I already know what the graph is going to look like because I can see x is between this negative number and that positive number. So I know that negative 17 halves is at approximately negative 8.5. So if that helps you for graphing. So here, we'll have an open circle at negative 8.5. We're going to have a closed circle at 1, and it's shaded in between those two values. Okay. All right, so it says real-world problems. The ideal length of a bolt is 13.48 centimeters. The length can vary from the ideal by at most 0.03 centimeters. A machinist finds one bolt that is 13.67 centimeters long. By how much should the machinist decrease the length so the bolt can be used? Okay, first of all, the length of the ideal bolt, is in between two values. Okay? Ooh, you can't even see what I'm writing. So the ideal bolt is in between these two values. So I'm going to write it as an and because I know that it's between. I'm going to write the ideal bolt is between. What's the smaller end going to be? If it has to be 13.48, but it can be more or less by 0.03. So we have to figure out what the maximum and minimum that it could be is. So 13.48, if you were to be less by 0.03, you'd be at 13.45. If you subtracted 0.03. If you added 0.03, you'd be at 13.51. Okay, and the reason I came up with that is because here, you're taking the 13.48 and you're going to add or subtract that 0.03 because that's how much error is allowed to happen. Okay? So an ideal bolt size has to be between these two numbers. Okay? Now, the machinist finds one that's 13.67 centimeters long. So the one he finds is 13.67, and he knows that it's too long, so he wants to subtract part of it or shorten it by something. How much is he going to have to shorten it by? So we're going to have to solve for x here, and then we're going to have a number that it's going to fall between. Okay? So the first thing that we're going to do is we have to subtract that 13.67. from all three parts. Now, in the middle, what is left? In the middle, what do you actually have? Not x. What do you have? Negative x, because it was subtracting x. Okay, so you can't forget that negative. That's often forgotten, but it cannot be forgotten. Okay. Over on this side, we have negative 0.22. Negative 0.16. Now what do I need to do to get x alone? What do I do? I'm not going to add anything. Right now it's being multiplied by a negative 1. Divide by negative 1 on all three parts. Uh-oh, what happens when we divide by a negative number? What do we have to do if we divide by a negative number? Flip signs, yes. So this is now, those signs have flipped. This is x, this is 0.22, 0.16. Now that looks funny to me because I like to start with the smallest number. So I'm going to write this completely in reverse. I'm going to start here. I'm going to write 0.16. The arrow is going to be pointing towards it with a line. Then I'm going to write x. Then I'm going to write the arrow pointing towards x. Then I'm going to write 0.22. So I literally took that statement and I flipped it completely over. Can you see that? Okay. That means that the bolt has to be shortened by somewhere in between 0.16 and 0.22 centimeters. Okay, this bolt that he found. So the bolt must decrease by 0.16 to 0.22 centimeters. So that's your answer there. Now, your assignment is the next page, which is your classwork, and then the following page. So there's your classwork. You're going to complete that. And then the next page is your assignment with another 11 problems on it. So the next 2 pages should be done. You'll have the rest of the time in class today to work on it. So you should be able to get pretty close to finishing. And then both of those are due. You can turn them in if you finish in class today, or you can turn them in on Google Classroom.